Good day, everyone. So I hope you are doing okay. So let's start with our first lesson. This is on electrochemistry. This is divided into several parts. So for this first part, we'll have a quick review on essential basic concepts which you have learned from your senior high school. But before that, we'll define what's electrochemistry. Electrochemistry is the study of electricity and how it relates to chemical reactions. Electricity can be generated by, as we all know, movements of electrons from one element to another in a chemical reaction, which we call as redox reactions. So that is why we'll have a quick review of this redox reactions. So this involves electrochemical processes. So again, electrochemical processes, these are redox reactions in which the energy released by the spontaneous reaction is converted into electricity. Or it could also be that the electrical energy is used to cause a non-spontaneous reaction to occur. So the layman's explanation or description of what's a spontaneous reaction is, let's say, for example, um, combustion, no? When something catches fire. So it's a natural process or phenomenon. It can happen very easily if you have all the components. If you have the fuel, you have the air, you have the oxygen, and then you have the, of course, the material that will undergo the combustion. So it can naturally occur. So that's a spontaneous reaction. Of course, the reverse of that is non-spontaneous, meaning a reaction will only proceed if, let's say, you subject the particular reaction solution with electric current. So with electric current or electrical energy, the non-spontaneous reaction can occur. So as what I mentioned, combustion is the most common example of redox reactions. So we'll have a quick review of what this redox reaction is. So from the word redox, so it means that there are two processes that occur simultaneously. So one is what we call as the oxidation, and the other one is reduction. So how do we know if it's oxidation or if it's reduction? We are guided by the oxidation numbers. So what we will look at is the change in the oxidation numbers of the elements, no, involved in the chemical reaction. So just like in our example here, our magnesium in the reactant, the magnesium, the oxidation number is 0. And then in the product, it's now positive 2. On the other hand, our oxygen in the reactant, the oxidation number is 0, and in the product, it's negative 2. So there is a change, obviously, in the oxidation number. For the magnesium, the oxidation number has increased. And for the oxygen, the oxidation number decreased from 0 to the minus 2. So each of these reaction corresponds to reduction and oxidation. So let's have a quick review again. You have covered this basically in your senior high school, but still we'll have a review of this. So again, when we say redox reactions, these are reactions involving oxidation and reduction of species. So there is redox because basically what happens is there is a transfer of electrons. So meaning from one element to another. And redox reactions, both reactions must occur or must happen simultaneously, meaning both the oxidation and reduction. So one would undergo oxidation and the other one would undergo reduction. So what happens in the oxidation process and in the reduction process? So we can be guided by this mnemonic device. I hope you can easily remember if you remember the oil RBG. So meaning O stands for oxidation. So it is oxidation if it involves an increase in oxidation number. Okay? And we will illustrate later on why uh, why is there an increase in the oxidation number. So there are two possible scenarios, no, in which our atom can undergo in a redox reaction, since it's involved transfer of electrons. So either our atom can lose electrons in the redox reaction, or our atom can gain electrons. So the result of this loss of electrons or gain of electrons, the result of this is the change in the oxidation number. Okay, so for oxidation, there is an increase in the oxidation number because our atom would actually lose electrons. So it involves loss of electrons. So the L here stands for, again, it involves loss of electrons. Okay, so why is there increase when an atom why is there an increase in the oxidation number if an atom loses an electron? So to illustrate, let's say the initial oxidation number of the atom is +3. So when the atom loses electron, let's say the atom loses, let's say, uh, let's say 2 electrons, okay? So remember that the charge of the electron is negative. So if an atom loses an electron, it becomes more positive. In other words, it gains a positive charge. So for every electron that is lost, the atom will gain a positive charge. So if the atom loses 2 electrons, it means it gains a positive charge. So the total charge now is from the initial, which is +3, then +2 from the 2 electrons that are lost. So the new oxidation number now, or charge, is +5. So there is an increase in the oxidation number. So this increase in the oxidation number again is brought about by the lose of by losing electrons, So on the other hand, our reduction, so there is a reduction when you would observe a decrease in oxidation number. Okay, and the decrease in the oxidation number is just a consequence when it's just a product when an atom gains electron. Okay, so to illustrate that indeed the oxidation number will decrease when the atom gain electrons. So let's illustrate. So let's have the same example. Initially, our atom has an oxidation number of +3, for example, and let's say it would lose electron. It would gain electron. So let's say that particular atom gain 2 electrons. So remember, the charge of the electron is negative. So when you gain an electron, you gain a negative charge. So you gain -2 here. So the total charge now is +3, and then -2. So what is that? That is a +1. All right. So from +3, indeed, it decreased into +1. So that's the consequence of the process, no? When of the reduction process, when our atom gains electrons. Consequently, its oxidation number will decrease. Okay. So going back to our example again. So our magnesium undergoes oxidation because the oxidation number increases from 0 and then becomes +2 in the product. And our oxygen undergoes reduction because initially it is 0 and then in the product it becomes -2. So the oxidation number is decreased. So maybe you are wondering, or I would assume that you also cover the rules in assigning oxidation number so that you can determine if there is a change in the oxidation number. So we'll also have a quick review on the rules of assigning oxidation numbers. All right. Again, before we go to the rules of assigning oxidation numbers, so once again, when we say oxidation, there is an increase in the oxidation number that is brought about by the loss of electrons of our atom. Okay, and reduction, there is a decrease in the oxidation number that's brought about by gain of electrons of our atom. So basically, class, basically, the redox reaction is a reaction between our reducing agent and the oxidizing agent. Okay, so from the word reducing agent, meaning it causes another substance to undergo reduction. So if we represent the other substance or another substance as AS, so the interaction of Ra and AS. So what happens? The reducing agent would cause reduction in AS. And for AS to undergo reduction, remember it must gain electrons. So in other words, what happens is that our reducing agent will lose electron. So our reducing agent will lose electron, and these electrons will be accepted by another substance or by AS. So in so doing, when this AS accepts electron, so it gains a negative charge, it undergoes reduction. Our AS is actually reduced. Okay? On the other hand, our Ra, after it donates electron, it is oxidized. Alright? And then, for the OA, so that just like our Ra, our OA will cause oxidation in another substance. No? So let's say, again, AS. So for this AS to undergo oxidation, so it must lose electrons, right? So AS would basically lose electron. That's the flow of the electron. So after the AS loses electron, it is oxidized. And after the OA accepts electron, it is reduced. So in other words, the effect is reversed. So reducing agent is the substance oxidized. Okay? Reducing agent is the substance oxidized. The oxidizing agent is the substance reduced. So basically the interaction between our Ra and OA. So the Ra donates electron to the OA. Okay? Ra donates electron to OA. After that, after accepting electron, our OA, our oxidizing agent, is reduced. And our Ra, after it gives electrons, it is oxidized. Okay? So that's basically the reaction between oxidizing agent and reducing agent. So if you look at our example here, okay, our example H2 plus F2 forming 2HF. So basically, our hydrogen undergoes oxidation from 0, and then the oxidation number now is +1. So that's increase, right? And then our F2 undergoes reduction. So that's from 0, it's now -1. So there's a decrease. So in this case, our hydrogen, since it undergoes oxidation, okay? So our hydrogen is oxidized. So it is our reducing agent, okay? Our F is actually reduced, meaning from 0 to -1, it is our it is reduced, so that is our oxidizing agent. So again, redox reaction is a reaction between the two, reducing agent and oxidizing agent. The reducing agent undergoes oxidation, oxidizing agent undergoes reduction. All right. So let's have a review again on how to assign oxidation numbers. Okay. So again, as a summary, this is the interaction between the OA and our RA. So our reducing agent loses electron, and that is accepted by our OA. Okay, so let's proceed to assigning the rules in assigning oxidation numbers. Okay, so we'll go through each of these rules. So these oxidation numbers, these are numbers arbitrarily assigned to our atoms, so based on some rules, which we'll discuss. So number one, so free elements or atoms in their natural form or atoms in uncombined state have an oxidation number of 0. So for example, the solid metals, sodium, beryllium, so metals in their solid form, meaning uncombined state, free elements, okay? And atom in their natural form, like example element hydrogen, the natural form is H2. The element oxygen, the natural form is O2. P4 for phosphorus. There's even S8 for sulfur or S4. So we call this one as allotropes, if you remember the term allotropes. Even carbon, we have different allotropes of carbon. So that's also 0. So the carbon graphite or even carbon diamond. So atoms in their elemental state or uncombined state, they are assigned with an oxidation number of 0. Okay. Rule number 2 is monoatomic ions. In monoatomic ions, the oxidation number is equal to the charge on the ion. So just to illustrate, no, just to distinguish how do we represent oxidation number from charge. So there is a distinction. So oxidation number, usually we indicate the sign first and then the magnitude. So we say +3, +2 for oxidation number. But for charge, it's the opposite, because the charge is a product of the uneven number of the charged particles, the protons and the electrons. That's why we have a charge. You know? If you have more protons than electrons, you have a positive charge. If you have more electrons than protons, you have negative charge. So the charge is represented by this symbol. We write the magnitude first and then the sign. Okay, just to have a distinction between oxidation number and charge. Okay, so let's continue with rule number 2. Number 2, in monoatomic ions, the oxidation number is equal to the charge on the ion. So for example, lithium plus, so the charge is +1, so that's also the oxidation number of that atom. Iron 3 plus, the 3 plus, the charge is also the oxidation number. O2 minus, that's also -2. So the oxidation number is equal to the charge. Okay, and then number 3, this is about oxygen. So usually the oxidation number of oxygen is -2, unless you would see some exceptions. Okay, so one exception is of course our oxygen. If it's in O2, that is 0. And then if it's in the peroxide, so we call this as peroxide ion. So it's just like you have a dimer. So you have a dimer, meaning 2 oxygen atoms are linked together, and the total charge of the 2 is 2 minus, and we assume that each of these oxygen contributes to the charge. Each contributes -1. Okay, so that -1 plus -1, that's equal to -1. So in peroxide, so we call this peroxide. Okay, so in peroxide ion, our oxygen is assigned with an oxidation number of -1. But usually it's -2, unless you see a few exceptions like our O2, that is 0, and then the peroxide, that is -1. Okay? let's go to the the next one, rule number 4. This pertains to the hydrogen. So usually, hydrogen, the oxidation number is +1 when it's part of a compound, okay? But there are some exceptions, few exceptions actually. So of course, we have already discussed, no? In rule number 1, in H2, that's the natural form of hydrogen, the oxidation number here is 0. The other exception is when you have when your hydrogen combines to a metal. So we call this one as hydride. So our hydrogen here is -1, like sodium hydride, okay, or magnesium hydride. Our hydrogen here, the oxidation number is actually equal to -1. Okay, then number 5. In number 5, rule number 5, group 1A metals, if they are in a compound, so the oxidation number is +1. Group 2, +2. And fluorine is always -1. So if you have, let's say, sodium chloride, okay, sodium is part of group 1A metals. So the sodium here has an oxidation number of +1. Let's say calcium carbonate. So calcium carbonate, that's the formula of the common chalk. So calcium is part of 2A, okay? So it's assigned with the oxidation number of +2. And then of course, fluorine, in all of its compounds, fluorine oxidation number is equal to -1. Okay, being the most electronegative element. Okay, but of course, F2, for F2, so the oxidation number there is 0. That's rule number 1, right? But fluorine in a compound, that is actually -1 in compound. Okay, that's -1. And then the next rule is the sum of the oxidation numbers of all the atoms in a molecule or ion is equal to the charge on the molecule or ion. Okay, so there is polyatomic ion. There's also, remember the compound or the molecule in general, the charge is actually 0. So it could be 0 for molecule, and then or ion, it's negative or positive. So the sum is equal to the charge. So for example, our bicarbonate, so the sum of the oxidation numbers of the atoms here is actually equal to the charge. Okay, so by definition, remember, if it's part of a ion or compound, hydrogen is +1, and then our oxygen is -2. So what is the oxidation number of carbon? So again, by simple formula, we can calculate its oxidation number. So from the formula, we have 1 hydrogen, so 1 times, and each hydrogen has an oxidation number of +1, then +1 carbon times x, let's say x is the oxidation number of carbon, +3 oxygen, and each of the oxygen is -2, and then the sum is equal to the charge, so -1. So that's 1 plus x minus 6 equal to -1. That's x is equal to 6 minus 6 minus 1, and then -1. So x here is +4. The carbon is +4. Okay, so the sum is equal to the charge for ion, and if it's a molecule, that's equal to 0. Okay, so for example, calcium carbonate again. So the sum, you don't see a charge, so the sum is equal to 0. But by definition, our calcium is +2, our oxygen is -2. So what is the carbon here? So the same process. So we have 1 calcium times +2 plus 1 carbon, so that's x, plus 3 oxygen times -2, that is equal to 0. Okay, so we have 2 plus x minus 6 is equal to 0. So x is equal to 6 minus 2, x is plus 4. Our carbon is plus 4. Okay? So basically, these are the basic rules in assigning oxidation number. So let's apply the rules in identifying the oxidizing agent and the reducing agent in each of the following equations or reactions. Okay, so for letter A, we have aluminum plus sulfuric acid, and then forming aluminum sulfate and hydrogen. So again, the first thing to do is you calculate for the oxidation numbers, so that you can determine which elements undergo change in the oxidation number. So let's start with letter A. So this one is a solid uncombined form. Our aluminum here is 0. Okay. And then our hydrogen here, by the rules in the assigning oxidation number in a compound. So this one is positive 1. Okay. And our oxygen is negative 2. So what will be the oxidation number of our sulfur? So again, we look at the formula. We have 2 hydrogen, and each hydrogen, the charge is plus 1. Okay, so plus 1 sulfur, so X, plus 4 oxygen times negative 2. So the sum is 0. Alright, so that is 2 plus X minus 8 is equal to 0. X is equal to 8 minus 2, that is equal to positive 6. So our sulfur here is positive 6. Okay, so on the other side, our hydrogen here is 0. Okay, and then our aluminum, since it comes from remember the formula writing. So aluminum sulfate comes from the ion, monoatomic ion aluminum 3 plus, remember, and the polyatomic ion sulfate. So our aluminum here is 3 plus. Plus 3. So our oxygen is minus 2. So what would be the sulfur? So the same thing. Okay, same process, no? So we have 2 aluminum. Each aluminum is it's from a monatomic ion aluminum 3 plus. So the most common charge is positive 3 for aluminum. So we have 2. Then plus how many sulfur do we have? We have 3 sulfur, so plus 3x. And then we have how many oxygen? 12 oxygen times negative 2 is equal to, there's no charge overall, that is equal to 0. So that is 6 plus 3x. 3x minus 24 is equal to 0. That's 3x is equal to 24 minus 6. Or that's 3x is equal to 18. So x here is positive 6. So our sulfur is oxidation number did not change. Alright? So what changed here? Aluminum and hydrogen. Okay? Our aluminum undergoes oxidation. From 0, it is now plus 3 in the product. So the substance that undergoes oxidation, that is our reducing agent. So our reducing agent is aluminum. Okay? And then our oxidizing agent is the substance, or it's the substance that contains an atom or element that undergoes reduction. So which one undergoes reduction? It's the hydrogen. From positive 1 in the reactant side, it's now 0 in the product. So the whole thing, the sulfuric acid, this is our oxidizing agent. Okay, not just hydrogen. The oxidizing agent and the reducing agent, these are reactants. So the whole formula. So the reducing agent is aluminum, and the oxidizing agent is our hydrogen. Alright? So let's go to letter B. So again, we still apply the rules in assigning oxidation numbers. So if oxygen here is -2, then the sum is 0. So our lead obviously is +2. And then for CO, our O is -2. So obviously our carbon here is +2. This is solid, so this is 0. Here, our oxygen is -2. Again, -2. But we have 2 oxygen atoms. You look at the subscript. So the oxidation number of carbon here is +4. So what changes? We have 2 lead. Lead, it's from +2 to 0. So this is reduction. All right. Our carbon from +2, it becomes +4. Sorry. So our carbon from +2, it becomes +4. So that is oxidation. So the substance that undergoes oxidation is our reducing agent. So the reducing agent here is our CO, and our because it's the C that undergoes oxidation, so it is the reducing agent. And our oxidizing agent, this is the one that undergoes reduction, so that's referring to lead. Okay, so our oxidizing agent is lead oxide. Okay, for letter C, again, this is just very simple. So hydrogen here is, because this is H2, this is 0, this oxygen is 0. Hydrogen here in the products +1, oxygen is -2. So what happens to hydrogen? It's from 0 to +1, so that is oxidation. And then our oxygen, it's from 0, it becomes -2, that is reduction. Okay, so the one that undergoes oxidation, that's our reducing agent, and that is hydrogen. And the one that undergoes reduction, that's our oxidizing agent, and that is O2. All right, so that ends part 1 of this discussion.